Imagine this for a second. You're standing on the 20th floor of a massive skyscraper, right in the heart of a bustling city like Bengaluru. But instead of looking out over rows of office desks and glowing computer screens, you are completely surrounded by rows upon rows of fresh, vibrant vegetables. Sounds a little bit out there, right?
Well, believe it or not, it's really not. This is a futuristic farm, and it actually produces way more food per square meter than any conventional open field could ever hope to. And here is the truly mind-blowing part. It does all of this while using 95% less water. It uses absolutely zero pesticides and zero soil whatsoever. Plus, it operates completely independent of the weather. That means you can harvest every single day, completely ignoring monsoon failures, heat waves, or droughts.
Welcome to today's explainer. We're diving into the absolutely fascinating world of vertical farming and controlled environment agriculture. Look, this isn't science fiction anymore. This is a massive, very real transformation in food production that's happening right now, both across India and around the globe. I'm super excited to guide you through exactly how this all works. Okay, let's just dive right in. Here's our roadmap for today. We'll start by figuring out what CEA actually is. Then we'll move up the technology ladder, from accessible greenhouses to soil-free systems, all the way up to high-tech aquaponics. Finally, we'll ground all of this by looking at the real-world economics and the actual steps you take to get started. All right, let's kick things off with Section 1. What exactly is controlled environment agriculture? At its core, controlled environment agriculture, or CEA, is a broad category of farming systems that use technology to control the growing environment. We're talking temperature, humidity, light, carbon dioxide, water, and nutrients. You can really think of this on a spectrum. On the simpler end, you've got basic greenhouses that just give crops a bit of protection from the rain. But on the highly sophisticated end, you fully enclosed vertical facilities totally automated by cutting-edge tech. And the reason this is taking off is simple. Traditional open field agriculture is, by its very nature, unpredictable. It's totally weather-dependent and seasonal. CEA completely flips the script on that. It's predictable, it's incredibly consistent, and it delivers high-quality crops year-round. It basically solves the absolute biggest headache for farmers and urban entrepreneurs: unpredictable weather. You get to optimize everything inside, no matter how chaotic things get outside. Which brings us to Section 2, accessible greenhouse farming. For most farmers in India, the most accessible entry point is the greenhouse, and there are three main types you'll see. First are polyhouses. These use a UV-stabilized film stretched over a steel frame to block out heavy rains that can trigger fungal diseases. They are super widespread across Karnataka for growing tomatoes, capsicums, and gerberas. Next up, you have shade nets. These use a woven fabric, so they're much lower cost and allow for great airflow while reducing intense sunlight. Fantastic for leafy veggies and nurseries. Finally, if you're willing to step up the investment, you get into climate-controlled greenhouses with active heating and cooling systems. Those are perfect if you're targeting premium retail channels in Bengaluru that want strawberries and exotic veg all year long. And why are farmers making the switch? Because the numbers don't lie. You can easily see yield improvements of 2 to 5 times with polyhouse cultivation when you compare it to standard open field farming for the exact same crops. It's a proven, massive game changer for productivity. Okay, let's step it up a notch. Section 3, soil-free growing systems. Once you take soil entirely out of the equation, moving into hydroponics, you've got a few brilliant methods to choose from. First is the nutrient film technique, or NFT. Here, a super thin film of nutrient-enriched water continuously flows right over the plant roots. It's incredible for fast-growing leafy greens. Honestly, an NFT setup can shrink a lettuce harvest from 60 days in soil down to just 25 to 30 days. Then there's deep water culture, or DWC. This is where the roots are actually suspended directly in a bubbling, aerated nutrient solution. You'll see this a lot with urban startups and home herb growers. Finally, drip hydroponics uses standard drip emitters, but instead of just water, it drips your hydroponic nutrient mix. This is the dominant method if you're growing heavier fruiting crops like tomatoes and capsicums. But here is the catch, and it's a big one. Nutrient solution management is the single most critical skill in all of hydroponics. Because your plants aren't pulling any nutrition from the soil, every single mineral they need has to be delivered through the water. You absolutely must keep your pH dialed in between 5.5 and 6.5. So grabbing affordable meters to track pH and electrical conductivity isn't just a recommendation. Those are absolute must-haves if you actually want your crops to survive, let alone thrive. Let's push all the way to the cutting edge now with Section 4, high-tech vertical farming and aquaponics. So outside in the real world, normal atmospheric CO2 sits at around 400 parts per million. But inside a high-tech, stacked, enclosed vertical farm, climate systems can literally pump that up to between 800 and 1,200 parts per million. When you combine that extra CO2 with custom-tuned LED lighting, delivering the perfect ratio of red and blue light, you dramatically accelerate photosynthesis and growth rates. Now, it's worth noting because of the high energy costs, this extreme level of tech is currently only economically viable for things like fast-growing microgreens or super high-value crops like strawberries.
And speaking of high-tech integration, we have to talk about aquaponics. It's just a beautiful, completely symbiotic closed-loop cycle. It works like this. You feed the fish in their tanks, and they naturally produce ammonia waste, which is actually toxic to them. But then, beneficial bacteria convert that ammonia into nitrate. Your plant roots come in and absorb that nitrate as fertilizer, which perfectly cleans the water. Finally, that crystal clean water flows right back to the fish. You're producing protein and vegetables at the exact same time. Here in India, farmers often use hardy tilapia, highly productive catfish, or even ornamental koi to create a totally separate income stream.
All right, let's transition to the most crucial part of this explainer, Section 5, economics and the actual urban reality.
Before you start drawing up plans for your farm, we have to talk money. 15 to 25 lakh rupees. That is the kind of upfront capital investment we are talking about just to build a standard 1,000 square meter polyhouse for vegetable production in India. And remember, if you want a fully equipped, stacked vertical farm with smart LEDs and full automation, you're looking at several times that amount. It's a very serious financial commitment. Which brings us to this sobering truth. Commodity crops sold through conventional channels at standard mandi prices will rarely, if ever, justify a CEA investment. The reality of the business is this. Growing the crop inside these perfect environments is actually the easy part. The real challenge, the thing that will make or break your entire operation, is finding the specific customers who will consistently pay premium prices to justify your heavy infrastructure and energy bills.
So how are urban entrepreneurs actually pulling this off? Well, there are some great proven models thriving in places like Bengaluru right now. You could launch a fresh herb subscription delivery direct to local households. You could supply premium, pristine salad leaves straight to high-end hotels and chefs. You could even grow edible culinary flowers or host educational urban farm experiences. Just one massive piece of advice. If you're doing this on a city rooftop, you literally must have a structural engineer check the building's load-bearing capacity before you bring in tons of heavy water systems. Absolutely crucial. That takes us to our final section, Section 6, how to get started. If you're feeling inspired, here is your advisory playbook. Number 1, do not overcomplicate it. Start with the absolute simplest proven technology for your chosen crop, maybe just a basic polyhouse, and master those environmental controls first. Number 2, secure your premium buyers before you pour a single drop of concrete. Number 3, go learn from people already doing it through local KVKs and agricultural universities. And finally, use the financial support available. Apply for MIDH subsidies, which can cover up to 50% of costs for a lot of farmers, and definitely look into NABARD financing to ease that initial sting. So I'll leave you with this question to chew on. Is controlled environment agriculture the right next step for your farming journey? Look, it's not the magic bullet for every single farmer out there. But if you're located near an urban market and you have access to capital, technical skills, and a bit of entrepreneurial grit, the opportunities here are quite literally extraordinary. I highly encourage you to go visit a local demonstration facility at an agricultural university. Seeing it in person will teach you more than reading ever could. Thank you so much for joining me today. Next week, our explainer is going to tackle agricultural biotechnology, diving deep into genetic modification and modern plant breeding, so make sure you subscribe to catch that. Drop a comment below if CEA farming is something you're seriously considering, and I will see you next time.